So today I want to talk about the number e, where it comes from, and just a little bit of how we're going to use it in our course. And I'm not going to go too into depth with all of the different applications of it or the entire history of it, but I just want to give you an idea of where it comes from. So what I'm going to start with is just looking at a couple of different functions and just looking at what happens when you plug in really small values of x and when you plug in really big values of x. And so the first function I want to look at is just 1 over x. And you can see the graph right there. Sometimes it's nice to look at it as a table instead. And I'm only going to look at positive values here. Okay. And so what I want you to notice is that if I plug in small numbers like zero point 0.1, it gives me 10, zero point 0.01 gives me 100, 0.000001 gives me 1 times 10 to the 7th. In other words, 1 with 7 zeros after it right there. In fact, every time I type in a small number, it gives me a big answer. So what I can summarize here is just that small x's come out to big y values. And similarly, if I go here to my table and I start plugging in big numbers, things like 99 or 999 or 999, you can see I get really small numbers out. Remember that a negative exponent means you're dividing by 10 that many times. So that is like dividing by 10 to the 8th power. That is a very, 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 very small number. So 1 over x is this great function that switches the size of your input. If you input a small number, you get a big number out, and vice versa. So next, what we're going to look at is what happens when you take your value of 1 over x and you raise that to the x power. Now what you'll notice is things changed. Let's delete this old table here. If you notice, the graph completely changed, completely different shape. So let's look at 1 over x raised to the x. If I make a table here, again, we're only going to look at positive numbers. We're going to look at small numbers again. 0.1, 0.01, 0.0001, 0.000001. You'll notice that the smaller that my number gets, the closer my y value is to 1. I can't actually make x equal 0 because that would mean I'd be dividing by 0. So that's why I have a little undefined right here. But you'll notice that as x gets really small, the y values get close to 1. So using the same kind of way of writing the answer as before, I can show you that small numbers approach 1. Now let's do the same thing we did with 1 over x. We plugged in big numbers. When I plugged in 99, you see this negative 198 power? That's crazy small. 999, it even just says it's equal to 0. It's not technically equal to 0. It's just so darn close to 0 you couldn't tell the difference. As I slide over here to the right, notice that even when I'm only at like x equals 3, x equals 4, my y value is practically 0. It tells me my y value is 0 as I slide to the right. So what am I noticing here? As I plug in big numbers, it approaches 0. So this is kind of weird. When it was just 1 over x by itself, all it did was switch small and big. Now, small goes to 1 and big goes to 0. What we're going to do next is change it just a little bit more. We started with 1 over x, we raised it to the x power. Now we're just going to add 1 to it. Now this should be somewhat surprising. Notice that my graph flattens out here. It's getting bigger because I'm taking a number that's bigger than 1 and I'm raising it to a power. And we learned in exponential growth that if you are raising a number that's bigger than 1 to a power, it's going to grow like this. So why does it not take off and grow like an exponential graph? Remember, like if I did 1.1, raise this, it takes off like that. Well, the reason it's not taking off is because we're not taking the same number and raising it to x. We're taking smaller and smaller numbers. Remember, 1 over x gets smaller and smaller as we go further to the right. So 1 plus 1 over x is getting closer and closer to the number 1. And you're raising it to bigger and bigger powers. 1 raised to the x is kind of a boring pattern. It's just flat. So the curve that I really care about is this one right here, where I'm taking numbers that are a little bit bigger than 1 and I'm raising them to bigger and bigger powers. Okay. Let's look at the table of values like we did in the other ones. If I make x into a small number, 0.01, 0.001, same sort of thing. I just get values that are close to 1. Maybe not too exciting about that. Small values of x are close to 1. But where it's a little bit more surprising is what happens if I plug in big numbers. That number right there might look familiar. In fact, it is equal to the number that I just typed in right down there. This value right here is what we get as we plug in big numbers for x. Big values of x get closer and closer and closer to the number e. So what I want to show you, the point of this video, is that the number e is actually approximately equal to 1 plus 1 over x to the x power when x is a big number. And this is actually where the number e came from historically. I'll give you the very short version of the statement here. Somebody asked the question, how much money will I have if I earn 100% interest, but instead of earning it one time a year, I earn that percent interest x times per year? And I want you to notice that x shows up twice in the equation. X shows up on the bottom, 1 over x, and it shows up on the top as an exponent. And that's the way that interest works. If you have something that's compound interest means you don't get all of your interest at the end of the year. You get it in little chunks throughout the year. So you can have compounded monthly, so you get a 12th of the interest 12 times throughout the year. You can have it compounded daily, where you get 365 times a year. And the question was, well, what happens if you compound it 1,000,000 times? What happens if you compound it 1,000,000,000 times? What happens if you compound it 1,000,000,000 times? What you'll notice is that the more times you compound it, the more money you get. But there's a limit to how much money you're going to get. If you look at the curve here, if I compound it once a year, I have $2. That's why 1 comma 2 is on the graph. If I compound it twice a year, I get, about $2 and a quarter, because I got 50% the first half of the year and then 50% of that. That gets me up to 2 and a quarter. If I compound it 4 times a year, I have about $2.40. If I compound it, 9 times a year, $2.58. But it doesn't keep going up forever. It levels off. So no matter how many times you compound it, you'll never earn more than E dollars. So that's one way to think about E, is it is the limit to how much money you'd have in your bank account earning 100% interest no matter how many times you compound it. Sometimes you'll hear that referred to as compounded continuously. So don't be afraid of E. It's just a number. It's an irrational number, and you're going to use it to build up different exponential models. So there you go. Comment, let me know what was confusing, and I will help out.